Hi, let's talk about thrombocytes. In this video, we'll talk about thrombocytes or platelets. We'll discuss how they work, and we'll also discuss the cytokine TPO and how it works. So, platelets aren't cells in and of themselves, but rather fragments of cells. They're derived from cells called megakaryoplasts. Now, megakaryoplasts come from myeloid stem cells in the bone marrow that differentiate into colony-forming units, megakaryoplasts, which then further differentiate into these megakaryoplasts. These are impressive cells. They're generally about 50 micrometers in diameter, so that's about, near 10 times the size of the average erythrocyte. They're also polyploid. They have up to 64 copies of the chromosomes in them, so it's quite an impressive collection of genetic material. Now, what happens is these megakaryoplasts, they make their way down to the sinusoids in the marrow. So when they reach the marrow sinusoids, they're much too large to enter, but they insert these processes called proplatelets into the sinusoids. They dangle in between the endothelial cells within the sinusoids, and the flow of blood shears these proplatelets off, and they're floating then in the bloodstream. And what's floating then becomes a thrombocyte or a platelet. So it's just a fragment of a megakaryoblast. And these megakaryoplasts will shed thousands of these proplatelets that turn into platelets. This is a process which is supported and modulated by the cytokine thrombopoietin, or TPO for short. Thrombopoietin, like most cytokines, exists in very minute levels, but it can ramp up very quickly. And so generally, within a microliter of blood, you might find between 150 to 400 of these thrombocytes. There are going to be more of these, so probably another 50 to 150 of them that are sequestered in the spleen for every 150 to 400 that are circulating per microliter of blood. They don't last terribly long, so they generally last, their lifespan is between 1 to 2 weeks. And when complete, these thrombocytes are phagocytized by macrophages in the spleen. And so you're just constantly producing thrombocytes as you go, and more can be recruited with the help of TPO as needed. Now, these platelets have a couple of functions. Probably the major function is to participate in coagulation. Now, it's not just about platelets with coagulation, but it's the combination of platelets and a particular protein called fibrin. So fibrin is a soluble protein that, in the presence of enzymes that occur in an area of vascular injury, start to polymerize. And so that soluble protein then becomes an insoluble polymer. That insoluble polymer is kind of like a mesh network. Now, that's part of the solution. That in and of itself isn't going to be sufficient to plug the hole. And what's next is that activated platelets need to come in. Now, thrombocytes tend to be these kind of amorphous blobs, and when they come into contact with a clotting factor called von Willebrand factor and collagen, or if they come into contact with fibrin, they activate, and they go from these amorphous blobs to having more kind of extensive pseudopodous processes, and they become enmeshed within this fibrin web, and they form a clot to prevent the escape of more blood. Now, in addition to working in coagulation, platelets actually can help modulate immune responses, both innate and adaptive. So their role in innate immunity is somewhat well known. They can secrete various modulators of inflammation, such as various cytokines, to help create an immune response. They can also adhere to various immunoglobulins and be very antibacterial in action. So they can be a partner of the adaptive immune system as well. So they're protective in two ways. Both they protect against exsanguination as well as protect against pathogens. And that leads us to a question here, and that is, what blood protein must thrombocytes interact to form a clot? Is it A, albumin, B, fibrin, C, immunoglobulin G, or D, immunoglobulin M? Well, we can rule out the antibodies there because they're participating in immune responses. That leaves us with two other classes of blood protein. Albumins are more in transportation and maintaining osmotic colloidal pressure, so that's not right. But fibrin is a good answer, because fibrin, when it polymerizes, is one major part of that clot with which activated platelets are going to interact to create. Thank you very much for your time.